In this last video from chapter 17, we're going to take a look at the formation of complex ions and the equilibrium that goes along with that. Our main objective is to define what a complex ion is, and then, of course, because we're in an equilibrium chapter, apply the concepts of equilibrium to it. So a complex ion is formed when you have a metal. Whoops, don't have my pen activated. Sorry about that. You have a metal like Fe+3, and it combines with a ligand. Whoops, that should be a G, not a Q. Okay, try again. Ligand. Okay, so we have a metal ion that combines with a ligand, in this case the thiocyanate ion is acting as the ligand, and this is a Lewis acid-base reaction. The thiocyanate is the electron pair donor, and the iron ion is the electron pair acceptor, and once that coordinate covalent bond has been formed, we have this complex ion, FeSCN+2. So the metal interacts with the ligand. We talked about this a little bit back in chapter 16 at the very end with the Lewis acid base stuff. This is a very pretty reaction in my opinion because the iron 3 ion in solution has sort of a yellowish orange color to it, but once you add the thiocyanate ion and this complex ion forms, the complex ion has this dark red color to it. So it's a very striking reaction as that complex ion forms. And that color change has a lot to do with how the ligand affects the d electron orbital energy levels on the iron. A lot of the transition metals have very colorful complexes, and it has to do with how those d orbitals interact with light. And if you change the ligand, you change the energies of those d orbitals, and so then you change the color of light that they will interact with. And so in the case of the Fe+3 ion, that actually the iron ion in water actually is coordinated with water. So water is serving as a ligand when iron has that orangish yellow color to it. But then one of those water molecules gets displaced by a thiocyanate ion and the color changes dramatically to this dark red color. And when we look at the reactions that form one of these complex ions, they are equilibrium reactions. And when we talk about the equilibrium constant for that, we typically use this F subscript, where the F just stands for formation. So this is the K of the formation, or KF.